Sorry. I have started recording once again, so let me actually share my screen. Am I clearly audible? And
Yes, sir.
is my actually like PDF file visible? You can see my PDF file, right? It's
Yes,
written
sir. Yes, yes, sir.
triple 203 lecture 8. So although I have said this is a like self-study thing, but I felt like yeah that would be quite harsh on a student. I don't know why didn't you actually join in like the last class? Maybe you had
There's a
actually
midterm,
midterm
math
exam. It's
midterm.
okay, no problem. But you all should actually have informed. Then I could actually manage my time better. So it's okay, no problem. That is not a big issue, especially in the university level. So today I will give you some hint since all the actually questions has have been actually solved uh, here. So I will actually give you the hint how to actually do some things. So most of the actually theorem we will be actually studying in the AC circuit are the same in DC circuit, whatever we have learned in the DC circuit. The only difference is we'll be like replacing all the resistance value with some impedance. So that impedance could be a combination of resistor capacitor or resistor capacitor inductor or something like this. So if we actually stick onto this, then all the analysis are the same with like compared to the DC analysis. So one of the like most like prominent method of solving electrical circuit is nodal analysis, and another one is called mesh analysis. So probably we have already learned the mesh analysis or loop analysis. So here we'll be studying the nodal analysis. So as I said, nodal analysis is the same as whatever we have learned in DC circuit. Just we must to actually consider the impedance like the resistance. So we'll be replacing resistance with impedance, and as you all know, like if we go for nodal analysis, then we'll get to know about the node voltage of the circuit. Means we can actually get the node voltage for the whole circuit. On the other hand, if we apply actually the mesh analysis or loop analysis, then we'll get to know the loop current. So this is our target. If we want to apply node voltage, node analysis, then as the name suggests, we'll get to know the voltages of each and every node. So this is one of the things. So we all know the node analysis will apply KCL, Kirchhoff actually current law, means at a particular actually node, the total contribution of current has to be zero. Means the algebraic sum of current should be zero. So in another word, it says the entering current should be equal to the leaving current. Means summation of entering current would be equal to actually summation of leaving current at particular actually node. So we all know the definition of nodes. So I'm not going to actually repeat these things because probably in this circuit you have learned a lot about it. So uh, in node analysis, your target is to first calculate all the node voltages. So let's say for this circuit, I don't know what did they actually ask us to calculate. Let's say they asked to calculate uh, like voltage across a inductor. So we have an inductor. So our target is to calculate actually the voltage across that actually inductor. But using actually node analysis, this is the thing. So if they ask you to actually solve something with nodal analysis, your target is to find out like how many nodes are there. So definitely this is a node, this is a node, this node is the same, so I don't need to write this is a node. So now the rule is if there is, since we'll be writing the KCL current law, means we need to know about current. So if there is any actually voltage source, remember we must write a separate equation for that voltage source. So the voltage source could be connected in two ways. Means the voltage source can be connected to ground. Then I have no problem. I can apply the normal KCL. However, if the voltage source is connected to other nodes rather than the ground, then we must use another method is called the super node or something. So later on we'll discuss about it. So the first target, as I said, in AC circuit will replace all the actually component, all the components in phasor format. Means will be actually drawing a impedance diagram. So if I replace this one in terms of actually phasor, so we all know these things, right? For the inductor, capacitor, and resistor. So I'm not actually repeating this. For inductor, the angle should be positive 90 degree. For capacitor, angle should be negative 90 degree. So if we actually redraw the circuit, it should be something like this. It should be something like this, and this is our target. Forget about this target. So my target is to write down node equation here, node equation here, and node equation here, so that we can actually get to know about the node voltage. Let's say this is the first node, second node, and third node. So the first node is denoted by 1, second node is denoted by 2, and third node is denoted by 3. Since there are only 3 variables, we need to write down at least 3 simultaneous equations. So let's say I have x, y, z. So I need ax plus, sorry, a1 b y1 plus c z1 equal to d1. This is equation 1. Then a2 x plus b2 y plus c2 z equal to d2. This is another equation. Then if I write a3 x plus b3y plus c3 z equal to d3. So if I have actually three unknown variable, so I must write at least 3 simultaneous equation, so that we can get to know about what is the formula of x, y, and z. So the formula can be using the Cramer's rule that we have learned in the last actually um, uh, like last class, and del z by del. So del is nothing but the actually matrix formed by the coefficient of x, y, and z. So this is for actually 3 variables. If we have 2 variables, we will use the same Cramer's actually rule to solve it. So as I said, if I have a voltage source which is connected like present in the nodal analysis, we must write a different equation for that voltage source. So for the voltage source, we don't need to write KCL. What we need to do, we need to check between which 2 nodes that voltage source is connected. So this voltage, that given voltage, is nothing the voltage between this point and ground. So ground voltage is 0. So actually V1, we already know the node voltage of first one, that is nothing but the source voltage, which is given here 12 in. So we already know this one. So basically we have 2 unknown variables, V2 and V3. So we need to write 2 equations because we already know this value. We need to write 2 equations consisting of V2 and V3. But the thing is very simple. So if we apply actually KCL here, if we apply KCL here, then what will we see? So the current, let's say the leaving currents are positive, so the incoming current should be actually negative. So we'll see some current will pass through in this direction, some current will pass through this direction, and some current actually pass through this direction. So what is this current? This current is nothing, V2 minus V1 divided by ZR1. This current is nothing, V2 minus 0, because this is actually connected to ground. So V2 minus 0 divided by ZL. And this current, this component is connected between V2 and V3. So V2 minus V1 divided by ZR2. So this is our target. Let's see, how do we actually write down the actual equation. So let's say this is our node 2. If we write down the node equation here, so this is a very simple node equation, V2 minus V1 divided by ZR1. Since we are writing actually node equation at node 2, so V2 should be positive, and other node voltages would be in the negative with respect to actually V2. So V2 minus V1 divided by ZR1. So this is one component. Then v2 minus v3 means we are writing for this. So v2 minus v3 divided by ZR2. So we got this term plus V2 minus 0, V2 minus 0 divided by ZL. So there's three branches in the current we have been writing, and there is no external current source connected to node 2. So that would be the equation. Then my target is to reorganize the equation in such way it would be a function of V2 and V3. So we will be taking out all the coefficient of actually v2 and then v1, and whatever the constant value we'll get, we'll actually take it in the right side. So if I rearrange like in a way, then it would be something like this. So we already know the value of zr1, zr2, and zl. So in complex mode, these are the complex number, right? These are all are the complex number. So in complex mode, we can perform the whole calculation. You don't need to write like this. So this is actually, this is 0 degree. This is also 0 degree, and there is some numbers. So if you actually use in the calculator, you will get exactly this value directly. You will get this value. Similarly, the coefficient of actually v1, you will get some values. Actually, this is 0 degree. So and within 0 degree. So but I prefer you should always write down in terms of actually complex number. Means even if it is actually a real number, you could always put zero 0.5 angle 0 degree. So there will be no chance of actually mistakes. So this is one of the case, and then you'll be writing actually KCL at node 3. So node 3, how many actually branches are there? 1, 2, 3. So three components are connected. So if I apply actually KCL here, so v3 minus v2 divided by zr2, then along this actually branch v3 minus 0, v3 minus 0 divided by zc, and then this one, since this is a current source, we don't need to write v divided by r. So I need current, so I will just write down I. So did you understand this part? Like why node 3 equation like this, v3 minus v2? So check v3 minus v2, v3 minus v2 divided by zr2, then v3 minus 0 divided by zc, and this current is leaving, it's a current source which is leaving, and this is I, so I will just put I. So these values is given, the value for I is given in the main circuit, so that is 4 0 degree angle, means 4 ampere current. So if I actually rearrange the equation, we'll take out all the coefficient of the v3 and then v2, and whatever the rest values, we'll actually take it in the other side, because we want to write down a equation consisting of v2, let's say a1 v2 plus b1 v3 equal to c1. This is equation 1, because equation 1 means from first actually node, and in another node, let's say this is a2 v2 plus v2 v3 equals to c2. So our target is from the node 2, is from the node 3. So my target is to rearrange the node equation in such way it would be a function of v2 and v3, because my target is to calculate what is the value of v2 and v3. So from first equation, you can see this is v2, so this is nothing but the a1. This is v3, so whatever other value, that is b1, and this is nothing but the c1. So if this is the case, similarly for the node actually 3, be careful, since we have been writing actually v2 first, whatever even the coefficient of v2 is negative or whatever the value is, we will always write down actually v2 first and then v3 second. Otherwise it will make a mistake in forming actually matrix determinant or something. So you can see first v3 we got some values. So if we actually perform the calculation, then we'll get to know about the final actually values after actually doing this like algebraic multiplication or summation or division or whatever the algebraic actually operations are here. So but be careful, we must write down the coefficient of v2 first and then v3 first. So if I write down this, then these two equation 1 and 2 would be looking like something like this. So from here we can easily calculate V2. So V2 would be nothing but the del. This is del. So del is nothing A1, B1, then A2, then B2. And for V2, it would be C1, then C2, then B1, then B2. Do you understand these grammar rules? Probably we have actually already learned, what is
Yes,
what
sir.
is the grammar rule. So now you all know the coefficient of actually A1, B1, C1, A2, B2, and C2. So we can easily calculate V2. Similarly, we can calculate actually V3. Similarly, we can calculate V3 using the same Cramer's rule. So once you get to know about V1 and V2, and now if I get back to the original circuit, so this is the original circuit. Once you are done with all node voltage, means now I know this node voltage V1, I know this node voltage V2, I know this node voltage that is V3. So all V are known. So Vi means I may be 1, 2, 3. So all actually node voltages are known. Then you look at the questions like what am I asked to do? Once you get to know all node voltages, you can calculate anything in that circuit. For if you are asked to actually do perform it in nodal analysis. So for our case, it's so simple. What is the voltage across that's inductor? That VL, that inductor is connected between this node and this node. So VL is nothing since the positive side on the upper side. So this is
V2.
V2 minus 0. So basically this is V2. This is so simple. If somebody asks us to calculate what is the voltage between R1, so my target is to let's say
Mhm.
calculate PR1. So I need to check uh, the R is connected between actually two nodes, right? So then node is V1 and V2. So this is nothing but the V1 minus V2. So everything will be simple. Let's just think about. No, I'm not asking you to actually calculate this. I want to calculate what is the current passing through this. What is the current passing through this in this direction? So I need to check, this resistance is connected between V2 and V3. So we can write down V2 minus V3 or V3 minus V2. But since the direction is actually pointing in the right, like forward direction, means V2 has to be actually greater than V3. So this current, let's say this current, this IR2, that should be nothing but the V2 minus V3, V3 divided by R2 or ZR2. Do you understand this actually method? Like what I'm trying to say?
Yes, sir.
It's so simple, right? So so this one is the case for node analysis. So this is so super easy, and I believe similar actually thing you can see for other node analysis. Uh, let's say here. So this sort of actually circuit is given once again, and you were asked to actually perform any actually things. I didn't even check what did they ask. Like for our case is we need to calculate what is the voltage across R3 resistors, but we must use actually nodal equation or node analysis. So once they ask to perform node analysis or nodal equation, so what we have to do, we need to actually find out how many nodes are there. We must actually calculate node equation for node voltage for each node. So voltages for actually each node. So if this one is the case, how many nodes are there? Although this is a node, will not perform because we can take resistance and this actually inductor as a single impedance. So think about, this is a node, this is another node, and this is another node. So let's say this is 1, this is 2, and this is 3. Now, can I replace these two as a single impedance? Can I do that?
Yes, sir.
Because this is a series combination, right? Can I actually replace this one as a single impedance? I don't know, like another Z.
Yes, sir.
This is another Z, and this is, let's say, another Z, Z4 or something. Is it possible to do so? This is so simple, right? What is Z1? Tell me. What is Z1? 7 plus 8 Z, right? Can I actually replace it to R theta format? We can do that easily.
Yes, sir.
Any confusion with that? Probably not. So similarly, for the Z2 and Z3, so what we have to do, it is already given. So the diagram is actually written here. So let's say ZR1, ZL1, then these two are series. So we'll get 7 plus 8Z. So 7 plus 8J, and if I perform actually, what is it called? Phasor format, then we'll get this one. So some people may write, this one like this, 7 plus 8J, then they convert it to actually phasor format. Otherwise, you can write down the phasor format from the beginning. What is the phasor of that R1? 7, then 0 degree, right? It's a resistive component. What is the actually phasor for this inductor? Means XL1, 8, then
So
angle 90
890
degree.
degree.
Negative
90 degree,
90
perfect.
degree. 90
So
degree.
if you perform this actually operation, you will get back to this. So there is no harm. Whatever you find it actually convenient, you can actually go for that. Do you understand what I am trying to say? Like you
Yes,
can
sir.
you can go for actually the phasor format from the beginning, or you can actually go for like Cartesian format first, then perform all the actual operations, mean the summation of like the parallel combination, and then you'll actually get back to the final phasor format. So it's up to you. So now if I convert all actually the resistor capacitors or resistor inductor capacitor into an impedance format, then we'll get into something like this, and it is so easy. Again, we are having actually three nodes. So just like the previous actually example, we need to write three simultaneous equation, but we'll always start with the voltage source. If we are actually doing some node analysis, our target is to apply the equation for the voltage source first. So since this voltage source is connected between a node and the ground, so this is so simple. I already know the value of V1. So that V1 is nothing but the E. So I need to write down the equation for other two node voltage, means V2 and V3, just like the previous example. How do you actually do so? I can write down the node equation here: V2 minus V1 divided by Z1, V2 minus 0 divided by Z2, V2 minus V3 divided by Z3. This is the three branches equal to 0. Any confusion with this equation? Can you check?
No,
Any
sir.
confusion with this equation? Like how did I get it? Or how to actually get this one? Probably not. So if this one is the case, again will actually extract all the coefficient of actually V2 in one side and the coefficient of actually V3 in another side, and the rest would be actually taken back to the right side. So the target is nothing but the A1, let's say V2 plus B1 V3 equal to C1. So writing the equation in this format, so this is our target. This is our whole target. So once you write like this, some may write in this format, or some may directly actually perform in the calculation in calculator. Means what is Z1, you know the value of Z2 and Z3, so you can write down directly 1 upon Z1 plus 1 upon Z2 plus 1 upon Z3. If you are using actually a calculator like ES series or E something series 991, then you can directly write like this, so there is no harm, and that is actually better even. So if you do so, we'll get an equation. Then we need to actually write down the actually node equation for uh, KCL for third node. So for this node, the current in this direction is V3 minus V2 divided by Z3. In this direction is V3 minus 0 divided by Z4. In this direction is V3, sorry, this is a current. So this is a negative current because it's entering, right? This is entering to the loop. So that should be negative I. So do you agree with this? V3 minus V2 divided by Z3. So V3 minus V2 divided by Z3. And then V3 minus 0 divided by Z4. That is the leaving current that I said. V3 minus 0 divided by Z4. And since this current source is entering, then I will just write down negative I. Do you understand this part? Hello?
Yes, sir.
Perfect. Then again, we'll actually extract the coefficient of V2 and V3, and but my target is to write V2 first and V3 second, because the equation should be A2 V2 plus B2 V3 equal to C2. That is the equation number 2. And then we will apply the Cramer's rule. Then we will apply to the Cramer's rule. So once we actually apply the Cramer's rule, we'll know what is the value of V1, that is already known, then V2 already known, and then we will know the V3. So once we actually get to know about V1, V2, and V3, then we'll look at the question, main question. What was the question? We need to find out the voltage across the R3. So R3 is connected between 3 and 0. So VR3 is nothing but the V3 minus 0. Do you agree with this statement? Hello?
Yes, sir. We are.
This is it.
Yes, sir.
Am I right or I'm wrong? I might be wrong, sometime. We should check. Okay.
Yes, sir.
So
It's true.
this is so simple. This is so simple. So there is a one more way to solve. Oh, in the exam, if nothing is mentioned, like you need to use node analysis, mesh analysis, or anything. So let's say I ask you to solve the same math, but I didn't mention anything about node equation. So you are free to do any sort of actual method. Means you can apply actually KVL here, you can apply KCL here, means the node analysis or mesh analysis, or even you see this current source and resistors are in parallel. So you can actually convert it into a voltage source along with a like series resistance using source transformation. Or some may say, no, I don't like it. I'll convert this E and Z1. Let's say, look at this. That E and Z1, this voltage source is connected in series with that Z1. So I can like convert it into a current source. Means if I consider this, I can convert it to a current source along with a resist like impedance Z1. So this is another way of solving. So it's up to you, completely up to you, how you choose to solve. But if I ask you explicitly, like use node analysis, then you need to actually use this method. Or if I ask you to solve in like loop analysis or mesh analysis, we must actually follow the KVL. Or if I ask you to use the source transformation, then we need to check whether actually a voltage source is connected in series with a like impedance. Then we can perform actually a source transformation. Means that current voltage source will be converted into current source, or the vice versa. Means that if we have a current source along with the resistance in parallel, then we can convert it into a voltage source with a series resistance, or sorry, series impedance. Am I clear? Means you all know these things, right?
Yes, sir.
So this could be a very good practice problem for your midterm exams. So what I can suggest, you'll check this circuit, or maybe you can open up a book, like let's say the Ballstead book, or then you'll find many examples, right, with node analysis, mesh analysis. You'll take any of this actually practice problem and give it a try and check whether you got the right answer or not. So this would be probably this actually topic would be the last topic for today. Have you ever heard of super loop and super node? Probably in this circuit you have learned, right? So what is called super loop and super node? So super node is applicable for KCL. If you want to apply KCL, then you may actually need to use super node. There is another term is called super loop. So super loop is related to
Super
KVL.
mesh.
Okay, super mesh. Yeah, no problem. Both are the same terminology. So super node is related to KCL or the node analysis, whereas actually super loop or mesh, super mesh is related to the Kirchhoff actually voltage law or the KVL. So what do they mean actually? So supernode it means like there is a voltage source. Since we are applying current, like KCL means, what is that KCL? Summation of current equal to zero, right? And what is KVL? Summation of voltage is zero. Is it like this? This is the very actually simple definition of KVL and KCL, right?
Yes, sir.
Okay, perfect. If this one is the case, you see, our target is to write down what would be the expression for current. So if the current is given, no problem, or we need to convert everything with current using this formula. So for our case is V divided by Z. So summation of V divided by Z or current, that has to be equal to zero. But sometimes the circuit is connected in such a way we cannot either find out what is the value of current or what is the value of V divided by Z means, like again, the equivalent term of actually current. In that case, we need to use supernode. Maybe that statement is bit actually messy and complicated to understand. In simple word, if we have a voltage source connected between two nodes, then we must to consider that two nodes as a supernode if we want to apply the node analysis or the KCL. So how about this? Like we had solved some math, right? Just actually we have solved two maths or discussed two math where we had actually a voltage source. But why didn't we actually use like super node, super actually node concept here? Because this nodes or this voltage source is connected between a node and another one is the reference node. So we don't need to apply any super node because we are not writing any KCL, no KCL here, right? Do we apply any actually KCL or KVL at the like
No, sir.
KCL at
In the
actually ground? Probably not.
no,
So
sir.
this is the reason. But if that voltage source is connected between any node, let's say V1 and V3, there is a voltage source connected, then I must to consider V1 and V3 as the supernode. If there is actually voltage source connected between V1 and V2, then we must to consider V1 and V2 as the supernode. Means these two nodes will behave as a single node. Do you understand my actually concern? What I'm trying to say?
Yes, sir.
Perfect. If you do understand the concern, so here we have a actually circuit, and in this circuit you can see there is actually voltage source that is actually creating all the problems. So this is a node. Let's say this is a node one, and this is another node, node two. But node one and node two are connected by a voltage source. So we don't know which current is passing through this. To be honest, even without applying actually what is it called, the super node, we can solve this. Maybe in another actually day, if you actually remind me, I will actually show you how to solve it. But for now, since a voltage source is connected between one and two nodes, our target is to consider these two nodes as super node. So how would we actually perform, like KCL in supernode? In order to see that, yeah, something is written here, whatever we are saying. So as I said, this one would be a node, this one would be a node, and the whole thing would be a supernode. Means if I apply actually KCL, if I apply KCL, then I will consider whatever is here and whatever is here. Will write all this actually like current summation of actually current in a single equation. So basically, supernode is nothing. We are combining two equations into one equation. Maybe I will explain a bit. Then it would be so actually like easy for you to understand. So first, look at the supernode. Means I'll write down the node equation here and write down the node equation here, but we'll exclude whatever the terms connected by the voltage source. So here, this V1 minus, since it's a current source, it's a living current. It's a living current. Is this current is living means this current is actually going outward of this actually node. So this one would be a positive current. So plus I1. Then for this term, is connected between V1 and 0. So V1 minus 0 divided by ZR. So I will write this term. Now I supposed to write another actually current equation here. Since it's a supernode, I will actually discard that part. So I will back go back to other actually node. So this is the other node. So what is this node? Let's say in the V2. So V2 will see this current is leaving. So I will put in a plus I2. And for this current is V2 minus 0, V2 minus 0 divided by ZC. Do you understand this equation? Hello?
Yes, sir.
Perfect. Then
So we need only to short circuit the voltage one.
will not consider anything with that voltage source because we don't know which current is passing through the voltage source. I will explain it a bit later, like how did we get the equation of supernodes. So just let me finish first, then I will actually discuss right now. So now, what will happen to the voltage source? As I said in KVL equation, if we have actually voltage source, we must to write different equation, means separate equation for that voltage source. Now, look at the voltage source. What is the expression for volt? The voltage source is connected between which node? The node 1 and node 2, right? And which
Yes,
side is
sir.
the positive side marked? The the right side, right? So
V2.
can I write down E is connected between 1 and 2, but 2 side is positive, so we will write down V2 minus V1. Do you understand this actually
Yes, sir.
expression? Okay. So from the supernode, we'll see we can write down the equation with respect to V1 and V2, and then the rest would be on the right side. So this is like ax1 plus b, sorry, ax plus a1x plus b1y equal to c1. So similarly, I am just writing in the KVL or the voltage equation for that actually voltage source. That is nothing equal to V2 minus V1. Do you understand why V2 minus V1, not V1 minus V2?
Yes, sir.
Yeah, because of
Positive
the
side is
polarity
a
actually given. Because of the polarity sign is given, right? So now we can write down this equation in that format, right? Let's say negative V1 plus V2 equal to E. Can I write down this equation like this? So this is like a1x plus b1y equals c1, and this one is like uh, a2x plus b2y equal to c2. Can I calculate x and y using Cramer's rule? We can calculate x and y, right? So x is
yes,
nothing
sir.
but the v1, y is nothing but the v2. So from that equation, from that two equation, now check what am I asked to calculate. I need to calculate what is the voltage across the capacitor element, or this actually capacitive element. So this capacitor is connected between node 2 and node 0, right? So Vc is nothing but V2 minus 0 equal to V2. So you already know the V2 value, that would be the answer. Now this is not our target because there's a so easy problem to solve. Now I want to actually discuss something about the supernode. So right now, if somebody don't want to go for supernode, like we have learned how to actually write equation for supernode, but we don't want to actually use supernode. How do you do so? We can do in this way. Check it out. So just think about this whole box is a black box. You don't know what is there inside in that black box. So we consider current is passing through this direction. So I will write down this is IB. So this is the black box. Okay, I don't know in which direction is current is flowing through. So you can choose in this direction as well. So tell me in which direction should I actually consider the current is passing through, because this is a black box, so we don't know anything. So give me actually option. Is this current passing through left to right or right to left? If you tell me left to right, I will consider left to right. If you tell me it's passing through from the actually right to left, I'll consider right to left.
So right to left.
Right to left, right to left. So I'll remove this part. Okay, let's say the current is passing through this direction as he mentioned. So now I will write a KCL at node at node 1. So this is node 1. So what is the node equation? This current I1 current is leaving, so I will write down I1. Then another equation is V1 minus 0 divided by ZR. So IB current is now entering to node 1. So I'll write down minus IB equal to 0. This is the black box current. I don't know the current. So this is equation A. So if this is equation A, now at node 2, at node node 2, so node 2, what would be that equation? The I2 current is leaving, so I will write down I2. Then for the ZC component, the equation would be V2 minus 0 divided by ZC. And the black box current, now it is a leaving current from V2 because it's going from V2 to V3. So plus IB equal to 0. Do you agree with this actually statement? You can take your time to understand. Any confusion with this? If you don't understand, please ask me. I don't mind.
So the IB current can be the direction of IB current can be changed for the two equations.
That's why in the
Oh,
beginning I asked you, since I don't know, in which direction the current is flowing through, right? So what we can consider, at the beginning we can consider the current is passing from the left to right or right to left. But if you have already considered the current is passing from in one direction to another direction, you can never change it in the middle of actually equations. So since we have considered is flowing from the right to left side, so I have already actually decided that direction. But if you had actually considered the direction from the left to right, you will get the same answer. The final answer would be the same. I will actually explain it again. So right now we are considering the black box current is passing from the right direction to left direction, from the second node to first node. So that's why we have written negative sign here, because it's the entering current for this and it's the leaving current for this. Do you understand this term? Now, how about
yes, sir.
other students? Are they trying to understand also? So if I have two
Yes, sir.
equations, if I add up these two equations, what will I get? Can anybody help me? Like V1 divided by ZR plus I1 plus V2 divided by ZC plus I2, that equal to 0, right? Because IB and I plus IB and minus IB will cancel out, right? So now the interesting thing will occur. How would you see this too? Could you see? I think that is fine. Now look at the equation of super node here, and now look at the equation I just got from combining two equations. Are these two same?
Yes, sir.
This is called super node. Super node means you don't need to write actually two different node equation and then get back to this. So if you are not familiar with, or if you are not like convenient with super node, you can always consider that actually the node sorry voltage actually source portion as a black box, and you can consider current in any direction, and then combine that two equations, you will get back to the same actually format. So right now maybe I can use a different color.
Sir, we could use V2 minus V1 equal E when E is given.
Yeah, because the E is connected between any two nodes, right? Let's say E is connected. This is a E is connected between Guru and Chagol. Sorry for writing actually Bangla here. My teacher always taught me in this way. So we must write down the equation for that E explicitly. So E would be let's say I said this is plus minus. So voltage at Guru minus voltage at Chagol. That I must write at the beginning. So if you don't write this, you'll not have enough equation to solve all the unknown variables. So now what I wanted to say, some may say, since it's a black box, so we don't know in which direction current is really actually flowing. If I consider current is flowing in this direction, this is IB direction now. Then when I have written actually equation for node equation for the first actually node, so you see the I1 current is leaving, so I wrote I1. The current for ZR is V1 minus 0 divided by ZR, so everything is okay. Now for that actually black box current, it is leaving, so we'll put a plus sign here. So if I put a plus sign here for this node equation, it's the entering current. So I will put a negative sign here. So it doesn't matter if I perform A plus B, means equation A plus equation B, still these two will cancel out. The black box current will be cancelling out. Do you understand? You will be ending up with the same equation once again.
Yes, sir.
Now is it clear?
Yes, sir.
Okay. So if it is clear, then you will be actually solving this, and you will get uh, the node voltage, and then whatever they ask you to calculate, no matter it's power, no matter it's actually voltage or current, you can actually solve everything. So this would be it for today's session, and best of luck for your midterm exam. If anybody has any problem with midterm exam, like he or she is not understanding any actually part of the syllabus, he or she actually may actually contact with me. I will try my best to actually like consult with that student. It's good to have a discussion in a group if needed. Otherwise, best of luck for your exam. Any questions so far?
No, sir.
Yeah. Do not miss the class once again. Otherwise, you'll get lots of actually self-study part, because I need to finish some syllabus. So this would be it. I have a few questions for all of you. আপনারা কি আমার ক্লাস বুঝতে পারেন? আর আমি খুব রাশ পড়াই অথবা খুব স্লো পড়াচ্ছি? ক্লাস কি
বোঝা
বোঝা
যাচ্ছে।
যায়?
আচ্ছা,
বোঝা
বোঝা
যাচ্ছে?
যাচ্ছে।
একটু মেসি, বাট বোঝার গেলে ভালো, আলহামদুলিল্লাহ।
স্যার
ঠিক।
অনেক টপিক থাকে তো, আর অনেক বড় বড় থাকে তো, তো হচ্ছে গিয়ে একটা শেষ করে আরেকটা পার্টের মধ্যে যখন যাই তখন আগেরটা হচ্ছে গিয়ে মানে ভুলে যাই, কিন্তু বুঝি না সেরকম না। যখন আবার রিভিউ করি তখন আবার জিনিসটা ধরে ফেলতে পারি এরকম।
এটা হয় স্বাভাবিক নয়? না আমরা হয়তো
জি
বা 10 বছর আগে পড়ছি, তারপরে হচ্ছে
জি
2 বছর,
স্যার,
তিন
স্যার
বছর, চার
এটাই
বছর ধরে
বললাম যে
একই জিনিস
আসলে
পড়ছি।
অ্যাকচুয়ালি কোনো
আপনার
প্রবলেম হয় না।
আপনারা ফার্স্ট পড়ছেন, তো এই কারণে টাইম লাগে স্বাভাবিক। কনসেপ্টের ব্যাপারে খুব ক্লিয়ার থাকার জন্য হচ্ছে টাইম লাগতে পারে। ইটস অল ফাইন। ঠিক আছে, আমি ওই জন্য বলছি যদি কারোর কোনো ধরনের প্রবলেম থাকে, আমার ইচ্ছে ছিল হচ্ছে যে গত ক্লাসে এই চ্যাপ্টারটা হচ্ছে কভার করা, আর আজকের ক্লাস রাখতাম হচ্ছে একটা রিভিউ ক্লাসের মতো, রিভিশন ক্লাসের মতো, যার যে কোনো প্রবলেম আছে প্রথম থেকে এই পর্যন্ত আমরা ডিসকাস করতে পারতাম, যেহেতু আমি কাভার করি নাই। আর লেকচার এইটা হচ্ছে এক্সামে ইনক্লুডেড। তো এই কারণে আজকে একটু ওভারভিউ দিলাম। ওয়াই ডেল্টা কানেকশন ইনশাল্লাহ থাকবে না, যদি লেকচার এইটা ওয়াই ডেল্টা কানেকশন আছে, আমি ট্রাই করব ওয়াই ডেল্টা কানেকশন হচ্ছে না রাখার জন্য এক্সামের জন্য, মিড এক্সামের জন্য।
স্যার যেহেতু
আর
কিছু থাকবে কিছু থাকবে না, তাহলে স্যার মানে টপিক গুলো মানে যদি নির্দিষ্ট করে লিখে দিতেন তাহলে ভালো হতো, যে কোন কোন টপিক মধ্যে।
অ্যাকচুয়ালি আই এম
তাহলে
নট
একটু
অ্যালাউড
সুবিধা
টু।
হয়।
ঠিক আছে, আমি বুঝেছি, বাট আমি এভাবে বলতে পারবো না। এই কারণে হচ্ছে আপনাদের আরেকটা সেকশন আছে, সেই সেকশনের টিচার যেটা আমাকে বলেছে যে ভাই এইভাবে বলেন না ওদের, ঠিক আছে? তাহলে বাট আমি আপনাদের একটু বলতে পারি, যতখানি পড়াইছি এর মধ্যে থাকবে, আহ, এবং কোশ্চেন হচ্ছে টাফ হবে না ইনশাল্লাহ। আর ওয়াই ডেল্টা কানেকশন থাকবে না, দ্যাটস ফাইন। ঠিক আছে।
রেলটাকে থাকবে না স্যার।
থাকবে না।
আচ্ছা
Any question? আমি তো লিখে দিয়েছি সিলেবাস মোটামুটি কি কি থাকতে পারে, প্যাটার্ন কি কি থাকতে পারে আমি লিখে দিয়েছি আপনাদের ইয়েতে। নভেম্বর 6-এ একটা হচ্ছে পোস্ট দিয়েছিলাম, ওখানে লিখে আছে। ঠিক আছে, তারপরে যদি কারো কোনো কোশ্চেন থাকে, কোয়েরি থাকে, ইউ আর লাইক এনকারেজ টু অ্যাকচুয়ালি ডিসকাস উইথ মি। থ্যাংক ইউ। ঠিক আছে।
জি স্যার।
আসসালামু আলাইকুম।
ওয়ালাইকুম
আসসালামু
আসসালাম।
আলাইকুম স্যার।
Yeah. We'll end our session here.